Okay, Chapter 5, Section 3, Metric Units. The objectives in this chapter or this section are going to be to convert units within the metric system and be able to think about things that are metric. For all technical and many trade workers, the ability to use metric units is important. Familiarity with metric units is also important for people who travel internationally or who interact with companies or other people who use the metric system. In many ways, working with meters, kilograms, and liters is easier and more logical than using our traditional units of feet, pounds, and quarts. The most important common units in the metric system are those for length of distance, speed, weight, and volume, area, and temperature. Time units, year, day, hour, minute, second, are the same in the metric as in the U.S. customary units. When we talk about the length, the basic unit of length in the metric system is the meter, pronounced meter, and abbreviated M. 1 meter is roughly equal to 1 yard. The meter is the appropriate unit to use in measuring your height, the length of the room, length of lumber, or the height of a building. All other length units used in the metric system are defined in terms of the meter, and those units differ from one another by powers of 10. For example, the centimeter, pronounced centimeter, is defined as exactly 1/100th of a meter. The kilometer is defined as 1,000 meters, and the millimeter is defined as 1/1000th of a meter. Because metric units increase or decrease in powers of 10, they may be named using prefixes attached to a basic unit. So a terabyte, the prefix is tera, is 1 trillion bytes. Gigahertz, megahertz, kilo stands for 1,000, centi is 100, milli 1,000th, and so on and so forth. So the prefix is hecto, a multiplier of 100, deca, a multiplier of 10, and deci, a multiplier of 1/10, were not included in the table because they are rarely used in the trades or even in technical work. The following length conversion factors are especially useful for workers in the trades. 1 centimeter is equal to 10 millimeters. 1 meter is 100 centimeters, which is 1,000 millimeters, and 1 kilometer is 1,000 meters. The millimeter unit of length is very often used on technical drawings, and the centimeter is handy for shop measurements. So here's kind of some pictures of what a millimeter would be compared to a centimeter. A centimeter is roughly the width of a large paper clip. 1 millimeter is roughly the thickness of the wire in the paper clip. 1 meter is roughly 10% more than 1 yard. One great advantage of the metric system is that we can convert easily from one metric unit to another. In the metric system, we simply shift the decimal point. Using unity fractions is also easy because we are always multiplying or dividing by powers of 10. So if we want to convert 348 centimeters to meters, we're starting out with 348 centimeters. Okay, I want to use the fact that there are 100 centimeters, and that was also up in the table. There are 100 centimeters in 1 meter. So I know that I want my answer to be in meters, so I want the centimeters to divide out. So we're going to use the same method. We're going to put 100 on the bottom, and we're going to put 1 meter on the top. So we would get our centimeters cancel out, 348 divided by 100, which is going to be 3.48 meters. So it says convert 7 centimeters to millimeters. Well, we're going to need to know how many millimeters are in a centimeter. Okay, so up here on our table, you can see that 1 centimeter is 10 millimeters, so we're going to use that. 1 centimeter is equal to 10 millimeters. So if we start out with 7 centimeters, and we want our centimeters to cancel out because we want our answer into millimeters, so we know that 1 centimeter should be on the bottom because we want the centimeters to cancel out and the 10 millimeters on the top. So 7 times 10 would give us 70 millimeters. The weight of an object is the gravitational pull of the Earth exerted on that object. The mass of an object is related to how it behaves when pushed or pulled. For scientists, the difference between mass and weight can be important. For all practical purposes, they are the same. The basic unit of mass or metric weight in the International Metric System is kilogram, pronounced kilogram, and the kilogram is defined as the mass of a standard platinum iridium cylinder kept at the International Bureau of Weights and Measures near Paris. The kilogram was originally designed so that it was almost exactly equal to the weight of 1 liter of water. 3 small metric units of mass also defined: the gram, which is 1/1000th of a kilogram, the milligram, which is equal to 0.001 grams, the microgram, and the metric ton, which is equal to 1,000 kilograms, is abbreviated T. We have these units here in this table. The gram is a very small unit of weight. It's equal to roughly 1 in 500th of a pound, or the weight of a paper clip. The milligram is often used by druggists and nurses to measure very small amounts of medicine or other chemicals, and it is also used in scientific measures. So if we want to convert 4,500 milligrams to grams, we want to use the conversion factor that 1 gram is 1,000 milligrams. So we've got 4,500 milligrams, and we want our final answer to be grams. So we know that we need the milligrams to cancel out. So the 1,000 would go with the milligrams, and we'd have 1 gram on the top. So we need to do 4,500 divided by 1,000, which is going to give us 4.5 grams. To convert 0.0062 kilograms to milligrams, okay, and we want our final answer to be milligrams, we need to use 2 conversion factors. We need to do kilograms to grams and then grams to milligrams. So we need our kilograms to cancel out. So 1 kilogram for every 1,000 grams. That'll get our kilograms to cancel out. And then we need 1 gram, because we want our grams to cancel out, for every 1,000 milligrams. So we're going to do 0.062 times 1,000 times 1,000 again. Okay, which is going to get us 6,200 milligrams. Because an area is essentially the product of 2 lengths, it is specified by a compound unit. So we've talked about this before. We might have meters squared, inches squared, but the unit is always going to be squared whenever you talk about area. It does give us this 1 hectare is 100 meters on each side, so the hectare is roughly 2.5 acres, or about the double the area of a football field. 1 hectare is 100 meters by 100 meters. So it says convert 456 square meters. So we're starting out with 456,000, meters squared and they want our answer to be in hectares. And we have this conversion up here that says that 1 hectare is equal to 10,000 square meters. So we want their square meters to cancel out. This is gonna, so we're gonna use this and this to make that happen. So we're gonna need to do 456,000 divided by 10,000, which is going to get us 45.6 hectares. Okay, let's talk about volume and liquid. So we're now starting to talk about cubic centimeters or cubic meters because we're talking about something that's three-dimensional. So when we have to convert 24 liters to cubic centimeters, so we're starting out with 0.24 liters, which is a unit of volume, but we want to convert it to cubic centimeters. This is going to be liquid, and now we're converting it to fill in a space. So we're starting out with 0.24 liters, and 1 liter is 1,000 cubic centimeters. Okay, and so when we multiply those two, we're going to get 240 cubic centimeters. We talk about speed. We've got 100 kilometers an hour is approximately 62 miles per hour, to kind of put that in perspective. So we want to convert 1,360 centimeters per second to meters per minute. Okay, the first thing we're going to have to do is change our centimeters to meters, and there's 100 centimeters in 1 meter. That will make our centimeters cancel out and us get meters. Now we need minutes. Well, there are 60 seconds in 1 minute. That'll make my seconds cancel out. So I'm going to need to do 1,360 times 60 over 100. Okay, and that's going to get me 816 meters per minute. We talk about temperature. We usually talk about degrees Fahrenheit or Celsius because most medications are measured in metric units. Dosage calculations often involve metric conversions. If a patient takes 60 milligrams of medication 3 times a day, how many grams will the patient take in 4 days? So 60 milligrams 3 times a day. So how many grams? So we really want the answer to be grams. And we're talking about how many times that they do that in 4 days. So 60 milligrams, and they take that 60 milligrams 3 times a day. So let's back up and do a different approach with this. So we know that we're going to take that and multiply it by 3 because we do it 3 times a day, and we're doing that for 40 days. I mean for 4 days. Okay. So that's going to get us a total of 60 times 3 times 4, 720 milligrams. But we really want to know how many grams that is. So now we can say, well, how many milligrams are in 1 gram? And there's 1,000 milligrams in 1 gram. So we're going to need to do 720 divided by 1,000 to figure that out. The length of a steel component is given as 8.6 centimeters. What is the greatest possible error of this measurement in millimeters? Okay, and so remember when we were talking about error, we're talking about plus or minus a certain 1/2 of whatever the smallest unit is. And so our greatest possible error, we're going to want to consider that we're talking about this 1/10 of a centimeter, because that's the smallest decimal place, the 0.6. And so we've got 0.1 centimeters, and we're going to multiply that or divide it by 2. Doesn't matter which way you want to. We're going to multiply it by 1/2 or divide it by 2. And when we do that, we would have 0.05 centimeters. Well, if you've got 0.05 centimeters, what is that in millimeters? Remember that there are 10 millimeters in 1 centimeter. So, teaching example right here, this is not going to work because we need the centimeters to cancel out. So we would have this backwards. We need it the other way around. So we have 10 millimeters in, actually I think we have 100 millimeters in 1 centimeter. Let's go back up here and check on our chart. Okay, so 100 centimeters is 1,000 millimeters, so that was just a difference of 10, not 100, sorry. You're right, 1 centimeter is 10 millimeters. Okay. So the centimeters would cancel out. Now, I want to know what the error is. So we would do 0.05 times 10, which would be 0.5 millimeters. Is going to be our error. So the cruising speed of a Boeing 787 is Mach 0.85, meaning 0.85 times the sound of speed, or the speed of sound. If the speed of sound at cruising altitude is 295 meters per second, what is the cruising speed of the 787 in kilometers per hour? So we've got a definition of what Mach means, and it says that 0.85 is what your Mach speed is, and that's the speed of sound. Okay, and it says if the speed of sound at cruising altitude is 295 meters per 1 second, okay, so that's what we're starting out with. What is the cruising speed of the 787 in kilometers per hour? So basically we're starting out with our, we've got a Mach of 0.85 times the speed of sound. Well, we take 0.85 times 295, and that's going to be in meters per second. We're going to get 250.75 meters per second, and they want kilometers per hour, so we need to change our 250.75 meters over 1 second to equal kilometers per hour. So let's work on the seconds first. So I know that there are 60 seconds in 1 minute. I know that there are 60 minutes in 1 hour. Okay, and now I've got my hours because my minutes are going to cancel out, my seconds are going to cancel out. Now let's work on our meters to kilometers. Well, I know that there are 1,000 meters in every 1 kilometer, so that's going to make my meters cancel out. So I need to do 250.75 times 60 times 60 again times 1, and then I need to divide that by this 1,000 that's on the bottom. And I'm getting 902.7 kilometers per hour. Okay. So a very active adult who wishes to maintain her weight of 128 pounds is on a diet of 2,300 calories per day. The nutritionist advises her to limit her intake of saturated fat to no more than 7% of her total calories. Fat contains 9 calories per gram. To determine the maximum number of grams of saturated fat she should consume per day, follow these steps. So we've got a 128-pound woman. The 2,300 calories per day is important because the nutritionist says that only 7% of that should be saturated fat, and that's what we're focusing on here. So let's take care of that first. So 2,300 times 7%, and remember 7% is 0.07. So 2,300 times 0.07 is 161 calories. So that she's supposed to eat that is fat. Okay. So fat contains 9 calories per gram. So determine the maximum number of grams of saturated fat. So we're starting out with 161 calories that she can consume. That is fat. And we want to know how many grams of, I guess, fat she can consume. So it tells us that fat has 9 calories per gram. So we're going to put 9 calories on the bottom for every 1 gram. The reason that I did that is so that my calories would cancel out and I would be left with the unit I needed. So I need to do 161 divided by 9 to get my final answer, which is 17.8, repeating. So if we want to round that to the nearest gram, we would say 18 grams would come from fat. In working with intravenous infusions, nurses often measure flow rates in drops or micro drops per minute while the solution itself is measured in milliliters. Suppose you've got a 750 milliliter IV and it must be given to the patient over a period of 6 hours. So this 750 has to be given over 6 hours. And the nurse must set the flow rate in drops per minute. So that's called the drop factor. For this solution, this drop factor is 15 drops per milliliter. The nurse must perform the following conversion. So we're starting out with, we've got 750 milliliters, and we're supposed to give that to the patient over 6 hours. Okay, so what are we trying to figure out? So it says if the drop factor for this solution is 15 drops per milliliter, the nurse must perform this conversion. So we want to convert this to drops per minute. Okay, and we know drops per milliliter. So we need, in the end, we need to know drops per minute. Okay, and what I know is that we're going to do 15 drops per milliliter. Okay, that would make my milliliters cancel out because my answer doesn't have anything to do with milliliters, but it does have to do with drops, so I don't want to get rid of that. Now I need to get, hours needs to be converted to minutes, and there are 60, I'm sorry, we need to put the 60 on the bottom, 60 minutes in 1 hour, okay, which is going to get our hours to cancel out. Now we have drops per minute, so we need to do 750 times 15 on the top, and on the bottom we need to do 6 times 60, and then we need to divide those two. So .25 drops per minute. Do we need to round on this one? I would say no, because if you round, you're going to get the wrong number of drops per minute. That might kill somebody. Here's some other conversion factors, and these are all going to be in one document under our course content that you'll be able to find. But here's some that you can look at. That was the end of Chapter 5, Section 3.